Welcome guys to another video, and in this video we're going to be talking about systems of equations and how do we solve a systems of equations. Okay, so the first thing we need to understand is that a symbol of equations is just a collection of two or more linear equations, typically linear. You could have different equations, but typically in Algebra 1, and which is the subject that some of you folks are taking, you're going to have linear equations. Okay, so let's take a look at this. Okay, so we know that, let's just make a graph real quick. So we know that a linear function or a linear equation is just y equals mx plus b. So the function may start like this, or the equation may start like this. This is just a linear equation, and it's written in y equals mx plus b form. This is the y-intercept. This is the slope, and this is just the y and x values. Okay, so okay, so systems of equations is basically just two of these linear equations. So let's say you have another one that comes down like this. That's another linear one. So in this one, the slope is going to be negative, so it's going to have a negative slope, but it's still going to be in the form y equals mx plus b. And if these two lines, if these two lines meet at one point, then that point is going to be our solution to the systems of equations. So that's going to be our solution. Okay, so if you have two linear equations that meet at one point, that one point is going to be our solution to the systems of equations, and this is going to be represented in an ordered pair type fashion. So this is going to be an ordered pair of x comma y. So the solution is going to be in x comma y format. So we're going to solve for x and y. Okay guys, so first we need to understand something. Okay, so we can always have different types of equations. Okay, so you're either going to have, so let's just make this little graph here, systems of equations. Okay, so we're gonna have here systems of equations little chart that you guys can learn from. Okay, so this one's gonna be like this. You're gonna have three parts, and okay, so let's make a little graph here on all three of them. So this one is going to represent a one solution graph. So like we saw before, you can have two linear equations, which that's a systems of equation, right? So that's going to, so let's say we have a line that goes like that, and then let's say we have another line, so another equation that goes like that. Our point of intersection is going to be here. So that means that this systems of equations has one solution because it intersects with each other one time. So it's going to have one solution. Okay, and this will be represented in so this is the intersecting, so it's it's intersecting, so it's one solution, and it's going to be in x comma y format. Okay, now you could also have another graph where the lines actually do not meet. So you could have two lines in y equals mx plus b format that meets at one point, but you could also have two lines that are actually parallel to each other. So what I mean by parallel, like this, they're actually just parallel to each other. When two lines are parallel to each other, they never meet because they keep going forever and ever. They're never going to meet because they keep going forever and ever without intersecting at one point. It's not like it's going to go like this and it's going to go, no, it's going to be straight, parallel. It's never going to meet. It's not going to be like that. That's wrong. It's going to be like that. It's going to be parallel to each other. Okay, it's going to be parallel to each other. So when the lines never meet, then you're going to have no solution because the lines never meet. When the lines meet, you have one solution. So you have no solution, and this is when you have parallel lines. Okay, Now, what could be this, like the third one? So what is the third scenario that you could have? Well, you could have, another graph where it's actually like this. You have the same y equals mx, so the line is just going to be over the line. So it's just going to be two lines that are exactly the same in y equals mx plus b format, but it's going to be exactly the same line. So what's going to happen in this one is just the same line. It's just two lines that that are on top of each other. One line is on top of the other one. So you're going to have, so what are the solutions for this one? So if this one is intersecting at one point and it has one solution, and this one has no solution because it's never intersecting, then what's going to be this one if it's always intersecting at all points? It's going to have infinitely many solutions. Which makes sense, right? Because these lines are forever and ever going, they're forever and ever going this way, and they're forever and ever going, up, right? So, like they're infinite lines, right? So, it makes sense because, they're both the same line, so they both share the same coordinates. So they have infinitely many solutions, okay? So typically, this one would be in x comma y format, so you would try to find the x and y. This one is actually going to be something like this. So like, let's say you have 2 equals 3, which is, we of course know is false. That's just going to be no solution because these don't match. And then this one is going to be something like 3 equals 3, which that's when we know it's infinitely many solutions, but we will get to that in a second. Okay guys, so now I wanted to introduce you guys to standard form, okay? So standard form is just when the line is in this form right here, ax plus by equals c. Okay, this is standard form. Now, what is the other form that we can see is the y equals mx plus b form. Okay, so you could either see, the equations in standard form, which is this form right here, or you could see the equation in y equals mx plus b form. Typically, when you see, this equation is going to be a little easier to find the solution, but, there's going to be methods that you can use to make this a little easier, but we're going to see that in the future. Okay guys, so let's take a look at this problem right here. We have problem number 1 right here. So this problem has two linear equations, and the reason why these are not as recognizable to some of you is because they are in what I just said before, in standard form. Okay, so these are in standard form. Okay, let me actually write this. Let me write this one a little bit over here to the bottom because I can't see. Okay, so these two equations are written in standard form. Okay, so which is this form. Okay, ax plus by equals c. So we're going to solve this using substitution. Okay, we're going to solve these two, or we're going to solve the systems of equations using substitution. Remember, solving for systems of equations is just finding the solution. So just finding where these two lines intersect. So on the graph, these two lines are going to intersect somewhere. So one's going to go like that, one's going to go like that, and that's our solution. Okay, remember from the graph, or from the table above, that's how it works. So these two lines must intersect at some point. Okay, so let's get right into it. Okay, so we're going to solve this using substitution. There's another method that's called elimination, which is typically used for standard form equations, but in this case we're going to use substitution. Substitution is actually mainly used in equations that are already in the y equals mx plus b form, but in this case we're just going to do substitution, just for the sake of explaining it. Okay, but in the next problem we're going to use elimination. Okay, so let's get right into it. So let me just erase this elimination one. So we're going to use substitution. Okay, so the first thing we need to do with substitution is we need to convert these two into y equals mx plus b form. Okay, so how do we do that? Negative x plus 3y equals negative 9. So let's just write the equation out, and we just need to isolate the y because we're solving for the y basically, right? So we just add x on both sides, because the x is on the right, and this, in this equation is on the left, so we need to move it to the right. Okay, so 3y equals x minus 9 divided by 3 on both sides, and you get y equals x over 3 is just 1/3 x. 1/3 x. That was a weird 3. I don't know why that was awful like that. 1/3 x minus 3. So that's one of the equations. So this equation is the same as this one. It's just this one is in y equals mx plus b form, right? Is in slope form, right? So now we need to do this one. This one's pretty simple. It's just x plus y equals 1 minus x, y equals negative x plus 1. So these are the two equations we have here. Now we're not done yet. We are not done. This is just like half of way done, okay? These systems of equations problems can be a little longer, especially when I'm doing it substitution and they are already in standard form. You know what I mean? Because it's going to take a little longer since we need to convert these into y equals mx plus b form, or slope form, right? So of course these are going to take a little longer to do when in substitution. Okay, so now we have these two equations here. So now this is where the substitution stuff comes in. Okay, so this equation has y equals 1/3 x minus 3. And this equation is y equals negative x plus 1. So what do you notice about these two equations here, guys? They both have a y equals, right? So this just means that we're taking this one, the negative x plus 1, and we're substituting it in for y, because, or vice versa, you could do the same thing. This one substituting in for y. We're just setting them equal to each other. That's all we need to do. So we can then solve for x. We're just setting them equal to each other, okay? So let's say, we're getting this one, y equals negative x plus 1, and we're plugging it in for y because y equals that one, right? So we're just setting them equal to each other. That's all you're doing here, okay? Once you get these two, substitution is just setting them equal to each other, okay? So you're going to have negative x plus 1 equals 1/3 x minus 3. So now we just solve for x in this one. So the first thing we're going to do is we're going to plus 3 on both sides. Always try to do the, the lesser number. So that, so 1 is greater than negative 3. So you're going to add this one to, to 1. But, you should have, you guys should have already learned that before. So negative x plus 4 equals 1/3 x plus x plus x. Remember, this just means that is a 1x. So we're just adding the coefficients. So you're going to have 1/3. Why do I keep making my 1/3 like that? I am very sorry, guys. 1/3 plus 1/1, which is just 1, right? So you're gonna make the denominators the same. You're gonna have 1/3 plus 3/3 is gonna be 4/3. So you're gonna have 4 equals 4x over 3. And what do we do here? We just multiply by 3. Multiply by 3. See, okay, so we multiply by 3, so what's that? 12 equals 4x, and we have 4 here. We have 4, and x was 12 divided by 4 is 3. So we have found our first coordinate pair, which is going to be, x comma y. That's the ordered pair, so that's the solution to the systems of equations, right? But we have just found that x equals 3, so the x is going to be 3, but we still got to find the y, right? So how do we find the y? Well, it's simple. We just go back to one of these equations here. So it's, let's go back to one of these right here, x plus y, and we just substitute x in and we solve for y. So what was one of the equations? It was x plus y equals 1, which is such a simple equation. So we already know that x is 3, so we're going to substitute it in for x. So we're going to plug it in for x. 3 plus y equals 1. And then we're going to do minus 3 here. Minus 3, solve it like a simple equation. Then we have y equals negative 2. So what does that mean? We substitute in that for y, and you're going to have 3 comma negative 2. So what does this mean? Remember, math is not about finding the numbers. It's about understanding what these numbers mean. So this ordered pair just means that on the graph, let's actually make this graph like that. On the graph, these equations, say we have this one right there, this is like 3 right there, and this is, and then we have this equation here. It's actually bad drawing. I'm sorry, guys. All right, this is do this again. I'm sorry. Okay, so that means that they are going to meet at say boom right there, and boom right there. Let's say this is 3 and this is negative 2. It's going to be this is going to be the solution to that system of equations right there. Okay guys, so let's take a look at this second problem right here that we have. So we have this problem right here, which is also in standard form. And in this one, we're going to be using the elimination method. Let me write this downwards here. This is going to be done by the elimination method. Okay, that's what we're going to do in this problem. Okay, so how do we do this? Okay, so let's rewrite the equations down here. X minus 2y equals -6, and x plus y equals 6. So let's make a line here in these two equations. Actually rewrite this one. Okay, let me rewrite this again. Sorry guys. X minus 2y equals -6. Okay, so we're going to solve this by the elimination method. Okay, so this method just involves canceling out one of the variables so that we can solve for one variable, which is just what we did with the substitution method, but it was a little different, right? So in this one, we just need to multiply the whole equation by something, right? So what we're going to do is in this case, we want to eliminate the y. You could eliminate the x, but in this case, in this example, we're going to eliminate the y, okay? So what you want to do is you want to make these y's cancel out. So we have -2y here, and then you have, well, y is just 1y, right? So you want to make these cancel out. So if we have a -2 here, what would make the cancel out right here when it's adding to it, right? Because this is just going to add, right? Well, it's going to be -2 plus 2, -2 plus 2 is 0. So, it's going to make it cancel out, right? So we want to make this 2, we want to make this 1y equal to 2y, okay? Because that's going to make it cancel out. So how do we do that? Well, we're going to multiply by 2 on this side, okay? So, we're going to multiply by 2 in this bottom equation. And in this one, we're actually just going to leave it the same. So we're going to leave it the same, okay? So you could also just look at this as multiplying this bottom equation's coefficient right here and just change the sign of this coefficient and multiply to the bottom equation, okay? If you guys don't get this now, you will get this later, what I'm saying about the coefficients and just, changing the sign. You start to see a pattern of how, these elimination methods work. But yeah, that's why the elimination method is a little bit more complicated than the substitution method, because, it requires you to understand how to cancel these out. This is the only, kind of hard step to do, okay? But it's not really hard once you start to see the pattern, okay? So, you could solve this using the substitution method. It's really just up to you which method you prefer. But I'm just trying to showcase you guys both methods, because this one is way more efficient when you have, equations that are in the ax plus by equals c format, okay? So let's take a look at this. So 1 times x minus 2 is just going to be the same. This is going to be the same equations because you're just multiplying it by 1. But this one's going to change. This one's going to be 2x. This is going to be 2x plus 2y. And then 2 times 6 is 12, right? So we're going to add these, okay? So that's going to actually cancel these out, because -2y plus 2y is 0. So these are going to cancel out, which is what we wanted, because we always want to isolate one variable. That's what we did in the substitution method. We isolated the y variable so we could set the equations equal to each other and solve for x, right? In this one, we're doing the same. We're isolating the x, right? So we're solving for the x one, right? So this is just 1x plus 2y, or plus 2x is going to be 3x, and then -6 plus 12 is just going to be 6. So if we divide 3, we're going to get x equals 2. So you see how simple that was? All you have to do is cancel these out, and then you get the x. You just add them and get the x. So now we just have to plug the x equals 2, of course, in one of these equations and just solve for y. So let's do this one, because this one's simpler. X plus y equals 6. You just plug in that for the 2, plus y equals 6, minus 2, these cancel out, and y equals 4. So the ordered pair is going to be 2, 4. So that means that this is the solution to this system of equations. Okay, guys, let's get right into problem 3. So in this problem, we're going to take a look at um, the infinitely many solutions types of equations. Okay, so remember, when you have an infinitely many solutions graph, you're gonna have two equations that are on top of each other. So they're basically the same equation because all their all all of their ordered pairs are the same. Okay, so if let's say you have f of 2 that equals 4, but then you have that's one of the equations, and you have g of 2 that's also going to equal 4. I don't know why I put a parentheses there, but they're just the same. Their ordered pairs are the same. Okay, so that's an infinitely many solutions one. They're always going to be the same. So that means that their ordered pair is just going to be the same. So you would have like the solution to for example, the x is going to be something like that, 2 equals 2, or the y is going to be like 4 equals 4 or something like that, right? But you know, if you don't understand that now, it's fine. We're gonna go over it right now. Um, I just need you guys to understand what infinitely many solutions means. It just means that one equation is on top of the other one, okay, or vice versa, whatever, right? So just take a look at these two equations here. They're in standard form, right? Um, but really just take a look at them. So this is x plus y equals 20, right? And this is 4x plus 4y equals 80. Do you guys not see like kind of like a pattern here? This is being multiplied by 4. This is also being multiplied by 4. And this is also being multiplied by 4. So what does this mean? Well, it just means that this equation right here is actually equivalent. It's actually an equivalent form to this equation because it's just being proportionally, it's being proportionally increasing. So let's say you have a fraction, 6/8. What is this fraction equivalent to? Well, this fraction, if you divide it by, say you divide it by 2, you're gonna get 3 and 4. So this fraction is also equivalent to 3/4 because if you 3/4 times 2 is 6, and times 2 is 8, right? So you see how these are proportional to each other, just like these two equations here. These two equations are just equivalent forms of each other. So what's that gonna mean? That means that they're actually going to overlap. So you're going to have infinitely many solutions. Okay, so let me just erase all this, But yeah, just really just keep in mind that those two equations are going to be proportional to each other. Okay, so they're going to be equivalent parts of each other. They're the same. They are the same equation. Okay, so let's see here. So we're actually going to solve these equations. Let's actually turn them into y equals mx plus b form. So just isolate, just isolate right there. I don't know why I put a, whatever. Y equals negative x plus 20, right? And then let's do this one here. 4x plus 4y equals 80. Minus 4x minus 4x. It's going to be 4y equals negative 4x plus 80. And then you have 4. You have 4. Then you have 4. It's going to give you negative 1. So it's going to be negative x, just like the other one. You see the pattern here, guys? So 80 divided by 4 is 20. And these two equations are the same. You see how these two equations ended up being the same once you converted them to y equals mx plus b form? That's because they're the same. They're the same equation. So on the graph, they're going to be overlapping with each other. Okay? So if you were to set these equations equal to each other, of course they are equal because so you're not going to be able to find one of the solutions because there's infinitely many solutions. But let's just see, right? So let's say you have plus x here. Let's say you're trying to like, what are you really going to be able to do? So this just cancels out and you get 20 equals 20, which just means that it's infinitely. And if you were to cancel out the 20s, you would have x equals x, which just means that it's infinitely many solutions. Okay, guys, let's take a look at this last example here that we're going to be doing. So we have we have another series of equations here, and this is also in standard form. Actually, all of these, equations are in standard form. But of course, you could have, equations that are in y equals mx plus b form, okay? But we're actually going to solve this using the substitution method and see what we get, okay? So let's see here. So let's just put the parentheses so we can guide ourselves, right? And we are going to cancel out we're actually just going to cancel out the y's first, okay? So we can solve for x, okay? So what are we going to do here? We can just take this 2 here, just put 2, and this one's going to be -1. Or you can just do vice versa. You could do, -2 and then just 1, but they just have to cancel out, okay? And what does this mean? It just means that when you multiply 2 times -1, that's going to be -2. And when you multiply -1 times -2, that's going to be 2. So if it's -2 plus 2, is going to cancel out. You could do vice versa. It doesn't matter. You just need the y's to cancel out. This is just the elimination method, okay? So then you're going to do something like that. And you're going to get here 2 times 2, 2 times 2x is just 4x. 2 times -1 is just minus 2y equals 2 times 2 is 4. -4x. Oops. I don't know if you guys are seeing the pattern here. I don't know if you guys are noticing this. Okay, and then this one is going to be 0, basically, because, Okay, so what do you guys notice about here? So when you actually are going to add them, what does that mean? 4 minus 4 cancels out. 0, right? 0 just cancels out. -2y plus, plus 2y cancels out because, it's 0. So it's 0, right? So this cancels out, 0, and then, you have this one, which is just, 4 plus 0, that's just 4. And then you have 0 equals 4. And, whoa, 0 does not equal 4. This just violated the laws of mathematics. Well, no, this just means that since 0 is not equal to 4, this just means that these equations right here are parallel, lines. So, these two equations have no solution. So what this means, when you have something like 2 equals 3, which we know is not true, right? We know it's not true, right? 0 does not equal 4, 2 does not equal 3, 5 does not equal 8. So when you have something like that, where you have a false statement, a false mathematical statement, you're going to have no solution. And remember, back to our chart, no solution just means that these two equations are going to be parallel. So they're going to act something like this, where they never meet. Okay, so this system of equations has no solution. Okay, guys, thanks for watching, guys. Thanks for sticking to the end. And I really hope you guys learned something today. I really hope you guys can apply this into your math classes and your SAT preps. And yeah, thank you guys for watching. Please make sure to like, comment, and subscribe, and stick around for later content.